Solution stoichiometry. So here we are going to touch back on stoichiometry. In reactions where you have aqueous reactants and products, it's often convenient to specify the amounts of those in terms of their molarity and their volume. And so we can do stoichiometric calculations using molarity instead of grams and moles. Grams and molar mass. So our general solution map for these sorts of things is going to be volume to moles to moles to volume. So this is just a twist on our original one, which was what? Grams to moles to moles to grams. Very good. Right? I told you that we're just going to chant it until we remember it. Grams to moles to grams. Well, we used grams here because we were given a mass of reactant. So that's great if you're given a mass. You know, if you've got a chunk of metal, you're going to have the mass. But what if you have 20 milliliters of a 1 molar solution? You don't want to have to calculate the mass of that. If we have the volume and we know the concentration, we just learned how we can calculate the number of moles of solute that way. And we're not going to even need the molar mass to do it. So let's do some examples. How much 0.125 molar sodium hydroxide solution do we need to completely neutralize 0.225 liters of 0.175 molar sulfuric acid solution? If you're just looking at the numbers, the units, molarity, liters, it kind of looks like that dilution problem, doesn't it? And that's where some people go off and they start doing a dilution problem. There's an equation here. This is molarity of sodium hydroxide and molarity of sulfuric acid. It's not the same chemical. It's not a dilution problem. Don't use the dilution equation. We're going to treat this as stoichiometry because it is. So what we did before was we used the balanced chemical equation to organize the numbers that were given to us, and we're going to do the same thing here. So here, 0.125 molar sodium hydroxide. We're going to write that under sodium hydroxide. 0.125 moles per liter. I'm going to translate that capital M. It's moles per liter. And then we've got 0.225 liters of sulfuric acid. So 0.225 liters of this. And the concentration is given, 0.175 moles per liter. 0.175 moles per liter. Oops. So stoichiometry, we always said grams to moles to moles to grams. But there are alternate pathways. So this is just starting from a different place. We're starting from liters. We're given a volume of this solution. We're given the concentration, the molarity. That is the conversion factor that allows us to convert from liters to moles. Stoichiometry calculations always have moles to moles in the middle. That's the core of it. What's on the outside of that can be different. So we're going liters to moles, and then they're asking us how much solution. How do we measure an amount of a solution? Liters, volume. So we're going to come down back to liters at the end. So this is our path. Let's adjust this here. Come on, what are you doing? Fine. Okay, that's our path. Liters to moles to moles to liters. It's just a twist. So we're going to start with what? We're going to start with the only volume that we're given. Both these molarities are conversion factors. So we're going to start with writing with highlighters, this doesn't work ever, does it? 0.225 liters of what? H2SO4. In stoichiometry, it's really important that we label them because it switches, and so we don't want to get confused. So liters of sulfuric acid to moles of sulfuric acid. To moles of the other thing, sodium hydroxide in this case. To liters of sodium hydroxide. Liters to moles to moles to liters. Liters to moles to moles to liters. Then we fill in the units underneath. Liters H2SO4, moles H2SO4, moles sodium hydroxide. And these get a little long sometimes when you're writing all those formulas in. If you can't fit them across your page, turn your paper sideways and write against the lines, write the long way. It'll give you more space. So we'll double check that all of our units are canceling each other out like they're supposed to. So here, moles of sulfuric acid per liter of sulfuric acid. This is the molarity. 0.175 moles. I didn't leave much room there, so I'm going to write kind of sideways. 0.175 moles. If you want a number on the bottom, it would be 1 liter. This middle part, where do we get the numbers for moles to moles? From the equation. Very good. So we have 1 mole of sulfuric acid reacting with 2 moles of sodium hydroxide. So 2 moles of sodium hydroxide for every 1 mole of sulfuric acid. And then at the end here, we're going to use the concentration of the sodium hydroxide. You don't want to get these two backwards because you'll get the wrong answer. And that's why it really helps just to write them under what they are so that you have them clearly labeled. So here, oops, doesn't want me to turn that way. I didn't leave enough room in the bottom, so I'll have to write slanty down here too. 125 moles per liter. So we go left to right, multiply by the top, divide by the bottom. 0.225 times 0.175 times 2 divided by 0.125 equals. What's the unit going to be? Liters of sodium hydroxide solution. My calculator is showing me 0.63. Anybody else get that? Okay. Is that the correct number of sig figs? How many sig figs in 0.225? 3. And in 0.175? And in 0.125? How many should this one have? How many does it have? 2. You guys are on it today. This is great. What do? My calculator didn't show me any more numbers. Add a 0, right? Because the next digit is 0. All the rest of the digits, according to the calculator, are 0. So put the 0 in there. Any questions? So there's like an infinite variety of questions that we can ask you now. It's a beautiful thing. Makes writing exams really easy because there's so many questions to choose from.